Good morning or good afternoon, dear distinguished chairs, respected committee members, and their colleagues. It is a pleasure and an honor to present our research today. My name is Rafid Mohammed Khaleefah. I'm from Iraq, and I work in University of Basra. And today I will be presenting our work entitled Multi-Scenario Simulation and Performance Analysis on Intelligent Transportation System based on VANET using SUMO and OMNeT++. This presentation focuses on evaluating intelligent transportation system using the vehicular ad hoc network through realistic simulation. This work combines traffic mobility and network communication to study different traffic conditions and road environments. And here we have the background and problem. In fact, with the rapid growth in the number of vehicles, especially in urban areas, transportation systems are facing serious challenges such as congestion, increased travel time, and road accidents. Traditional traffic management approaches are no longer sufficient. This creates a strong need for intelligent systems that can monitor and manage traffic dynamically in a real time. And about the research objectives, in fact, based on these challenges, this research aims to design and evaluate VANET-based intelligent transportation systems using simulation. Especially, we analyze how different arrival rates, road types, and vehicle speeds affect traffic performance. We also validate our simulations using real road maps to increase realism. And about the literature review and the state of the art, we can say that the previous studies have shown that VANETs can significantly improve ITS performance, and many works have used SUMO and OMNeT++ for simulation. However, most of these studies focus on limited scenarios or a small number of metrics. Our contribution fills this gap by providing a multi-scenario analysis, including real map-based simulation and multiple performance parameters. And in the methodology overview, we can say to achieve our objectives, we used unintegrated simulation framework. SUMO was responsible for realistic traffic mobility. OMNeT++ handled the network communication, and the VINS framework enabled real-time interaction between them. This integration allows vehicles to react dynamically to both traffic and communication events. Then we have the simulation scenario design. In fact, several simulation scenarios were designed in order to capture different traffic conditions. These include a simple baseline road, arrival rate analysis, highway and urban environments, trip time evaluation, multi-speed vehicle scenarios, and finally real map-based simulations. Together, these scenarios provide a a comprehensive evaluation of ITS performance. Then about the implementation details. For each scenario, we carefully defined parameters such as road length, speed limits, number of lanes, and vehicle arrival rate. These parameters were selected to represent both realistic and controlled traffic environments, enabling consisting and comparison between scenarios. And we have here key results. The first one is the arrival rate lambda analysis. One of the key findings of this study is the direct impact of the arrival rate on traffic behavior. As the arrival rate increases, the traffic density increases accordingly, leading to a higher congestion and longer trip times. The computed arrival rates were validated and matched the predefined simulation values. Then we have here the key result. The other one is the road type compression. When comparing the highway and the urban scenarios, we observed clear differences in traffic performance. Urban roads are more sensitive to increasing traffic density due to lower speed limits and frequent intersections. In contrast, highway scenarios can accommodate higher arrival rate more efficiently. Then, also from the key results, the trip time evaluation. The trip time was measured between two non-points on the road. The simulation results were consistent with the theoretical calculations based on distance and speed, which confirms the accuracy and reliability and of course of the proposed simulation frameworks. Also then, from the key results, we have the multi-speed vehicle analysis. In mixed speed traffic scenarios, vehicles with different speeds coexist on the same road. The results show that speed variation significantly affects traffic flow and vehicle interaction, which highlights the importance of considering heterogeneous vehicle behavior in ITS design. Then also from the key results, we have the real map-based simulation. In this part of the study, a real street map was imported from OpenStreetMap and used directly within the SUMO simulator. The selected road was also cross-checked with Google Maps to ensure accuracy. This allowed us to observe a realistic traffic behavior that closely reflects real-world driving conditions, rather than relying on synthetic or idealized road models. Then we have the results. This slide summarizes the main experimental results obtained from different scenarios of the simulation. Of course, the results illustrate the impact of vehicle arrival rate on congestion and trip time, highlight the difference between urban and highway environments, and demonstrates how speed heterogeneity affects traffic flow. In fact, these findings are further validated using real map-based simulations. Discussion. The discussion highlights how traffic performance is highly sensitive to vehicle arrival rates, especially in urban environments. Also, the urban roads react more sharply to density change due to limited capacity and intersections. In addition, introducing multiple vehicles speeds significantly affects flow stability and cognition patterns. Finally, the real map simulation demonstrate that the proposed approach is scalable and applicable to real-world road networks. Then we have the conclusion and the future work. Yes, here in conclusion and the future work. In conclusion, this research confirms that VANETs play a critical role in improving the ITS, which is the Intelligent Transportation Systems. The integrated SUMO and OMNeT++ and VANET framework provides a reliable and scalable platform for evaluation. As future work, we plan to incorporate security mechanisms and AI technique use to further optimize traffic performance. Recommendations. Based on obtained result, several recommendations can be highlighted. First, VANET-based intelligent transportation systems are mostly suitable for dense urban environments. And second, using the realistic maps and mobility model significantly improves the credibility of simulation results. And finally, further evaluations should always consider mixed traffic condition and integrated simulation platforms. Okay, this brings me to the end of the presentation. I'm sorry I spoke quickly in order to keep to the time limit. I would like to sincerely thank the conference organizers and the scientific committee for their efforts in organizing this valuable event. Thank you all for your time and kind attention. Thank you so much.